Today what we're going to do is we're going to take our bivariate data, the two variable data, and we're going to create graphs called scatter plots, and we're going to talk about correlation and trend lines. So often statistical studies are done when data is collected in two variables. We called that bivariate, which is two variables. You remember univariate means one variable. And what we're doing is we're looking for a relationship between the two variables. So is there some type of relationship perhaps between a person's height versus their weight? Or is there a relationship between the number of hours that you spend studying and your height, for example, which of course there would be no relationship there. A scatter plot is a graph that relates the two sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant because the data is usually positive numbers. Remember, when we're talking about real-world situations, we are typically in the first quadrant because we can't have negative time or negative distances or something like that. Unless we're talking about temperature. If we're talking about temperature, sometimes we'll have negative values. Once we create a scatter plot, we use the scatter plot to find trends in the data. So what's happening with the data? Is there some type of relationship that we see? So you're going to see three different types of scatter plots. What I want you to notice, first of all, in a scatter plot, you do not connect the points. A scatter plot is literally just dots of ordered pairs. We are never connecting the points in a scatter plot. And you have to see three different types of scatter plots here. The first type of scatter plot, the trend of the points tend to go uphill. And when I have a line that tends to go uphill, I have a positive slope. There's a positive slope to this line that I just created. So we call that a positive correlation, meaning that as one variable increases, the other variable also increases. So the one variable is hours or minutes of time spent studying, and the second variable might be the score on a test. So the more I study, the more minutes I study, the greater my score. Both variables are increasing. Now in the next situation, the trend of the ordered pairs here is to go downhill, and if I were to create a line, that would look like a negative slope. So when I have a negative slope, we call that a negative correlation in the scatter plot, meaning as one variable increases, the other one decreases or goes down. So perhaps the faster I drive, the worse gas mileage I get. My gas mileage goes down. So that would be a negative correlation or a negative relationship. Now, if the scatter plot or the points in the scatter plot are all over the place, then I have no correlation, meaning that the two variables are not related. So perhaps the speed that I drive to work and the grade that I get on a test. There's no relationship between those variables, so the correlation or the scatter plot would show the data points all over the place. Okay, so for the first example, what we're going to do is we're going to take the data and create a scatter plot. So this table shows the altitude or height of an airplane and the temperature outside the plane. So the altitude is the first variable, so we're going to make that our x-axis. And the temperature is the second variable, so we're going to make that our y-axis. And what we're going to do is we're going to create a scatter plot of the data. So we're just going to create ordered pairs based from the altitude and temperature. Just like in a histogram, you need labels for your x-axis and for your y-axis. And you need an appropriate scale on both. Now for my x-axis, I have to go from 0 all the way to 5,000. So what I'll do is I will count by thousands, but I'm going to skip a couple lines here. So I'll skip a line. Essentially what I'm doing is counting by 250. So I'll skip a line 500, skip a line 1,000, skip a line 1,500, skip a line 2,000, skip a line 2,500, skip a line 3,000, skip a line 3,500, skip a line 4,000, skip a line 4,500, skip a line 5,000. Now my temperature goes from 59 all the way down to 0.6, so I don't want any breaks in my y-axis either. And if I have to get all the way up to about 60 degrees, I'm going to count each line by 5. So I'll go 5, 10, 15-20, 25-30, 35-40, 45-50, 55-60. Now I have my scale and labels all set, so now I just start plotting ordered pairs. So the first ordered pair I have is 0, 59.0. The second ordered pair is 500, 59.2. And again, we're going to be approximate because it's hard to get exactly the temperatures, right? So at 1,000 feet, I've got 61.3 degrees. At 1,500 feet, I've got 55.5 degrees. At 2,000, I've got 41.6. At 2,500, I've got 29.8, or just about 30. And at 3,000, I've got 29.9, so again, very close to 30. At 3,500, I've got 18.1, so just below 20. At 4,000, I've got 26.2. At 4,500, I've got 12.4. And at 5,000, I've got 0.6. So that's our scatter plot of the altitude of a plane and the temperature outside. And then once again, do not connect the points on a scatter plot. Okay, if you need time to catch up with the scatter plot, you can certainly pause the video. I will pause for a minute, and you can come back to the video once you finish your scatter plots. Okay, so once you finish your scatter plots, now we're going to look at the type of relationship that the scatter plot goes. So we're going to look at the trend for the points, or for the ordered pairs. And since the trend of these ordered pairs seems to go downhill, that means I have a negative correlation. Meaning as one variable increases, the other variable decreases. So in this case, as the plane gets higher, the temperature outside starts to fall. So now what we're going to do is we're going to graph a scatter plot on the graphing calculator. And I've got the steps written here. We're going to go into Stat Edit and type the data into L1 and L2. So at this point, what I want you to do is open up the calculators, and you're going to do the altitude in L1 and the temperature in L2, and then while you're doing that, I want you to pause the video, and I'll come back to show you how to get the scatter plot on the graphing calculator itself. So go ahead and press pause on the video. Okay, so I have my data in L1 and L2, and now what I'm going to do is turn my stat plots on. So it says turn on stat plot. In order to do that, you're going to hit the second button, and then Y equals. So to turn on your stat plot, you're going to go second, Y equals. And you'll get your stat plot menu, and notice for number 1 it says off. So I'm going to hit enter, and I'm going to turn it on. And if you go under type, it shows a scatter plot there already. So we're all set there. And then to actually see the scatter plot, I'm going to hit zoom and then zoom stat. So I'm going to scroll down to zoom stat, hit enter, and there's my scatter plot. So you can see the scatter plot that we created right on the graphing calculator. And we're going to have to be very comfortable with doing the scatter plots on the graphing calculator for the next several days. Okay, so on to the next question. When two sets of data have a positive or negative correlation, you can use what we call a trend line on the scatter plot drawn near the points to show the correlation, which is what I did on the first page. You can use the trend line for interpolation or extrapolation. Interpolation means you're estimating a value between two known data values. So if I know what, for example, the age in months, I jump from 6 to 8. If I wanted to know what 7 months would be, I would interpolate. And then extrapolate means you're predicting a value outside the range. So what we're going to do in our next scatter plot is we're going to make a scatter plot of the data and then approximate the weight of a 7-month-old panda. So what I want you to do at this point, I want you again to pause the video, create a scatter plot, and then draw in a trend line. In other words, draw in a straight line that best fits a lot of the data points. You can't make it, you're not connecting the dots, just a straight line, kind of like I did on the very first page of the notes. So go ahead and pause the video. When you come back to the video, I will have my scatter plot finished and my trend line drawn in. Okay, a couple things I want you to notice is we skipped months 5, 7, 9, and 11. So make sure your scatter plot, on your scatter plot, you don't have ordered pairs for month 5, excuse me, 7, 9, and 11. And you draw on your trend line. Again, it should be a nice straight line. You're not trying to play connect the dots. Notice my line doesn't hit every single point right in the middle. We're just trying to get a nice, an estimate, a nice estimate. Okay, so now what we're going to do is we're going to write the equation of a trend line. Now, prior to this chapter, in chapter 4, you used to have to figure out a line based on the slope and y-intercept. But now that you know how to do a linear regression, we're going to find the equation of the trend line by doing a linear regression. We already have the data in L1 and L2. Or I'm sorry, we have the data from the first question. So what I want you to do is we're going to put the data in L1 and L2 and then go over to Stat, Calc, Linear Regression, just like we did in review class. And you're going to have your data in L1 and L2, run the regression to get your regression equation. So press pause and I'll come back with the regression equation. Okay, so I ran my linear regression, and notice my work. I wrote Stat, Calc, Lin, Reg. That's my work for doing a linear regression. And I spelled regreen. I don't know what that's all about. Regression. And I ran the linear regression, and I got the equation y equals 4.9x minus 2.5. So that's the equation of my trend line. That's the line that best fits the data. Now the question is, what is the approximate weight of a 7-month-old panda? So I need to find the weight, which is the y value, when the panda is 7 months old, which is the x value. So all I need to do to estimate, I can use my scatter plot and look at the trend line, or I can say, well, if since months is x and I'm looking for the weight, which is y, I substitute 7 in for x, and I use the equation of my trend line to get the age of a 7-month-old panda. So 4.9 times 7 minus 2.5. And I end up with the approximate weight is about 31.8 pounds. And if we look at the scatter plot, if I were to look at 7 months old, we're going to be a little bit over 30 pounds. And according to my trend line, I'm at 31.8. Okay, so now for your homework tonight, when you're working on your homework, you're going to be creating scatter plots, and you're going to have to draw in the line of best fit, and then it says also write the equation of the line of best fit. You're going to use Stat, Calc, Linear Regression to do that.